So welcome to range-based for loops. In this video we're going to be introducing containers and iterators very briefly, using a range-based for loop in Unreal, gently introducing the auto keyword, and finishing our isIsogram method. By the way, you can read more about range-based for loops from the Unreal standpoint using that URL there. So just before we deal with our fancy range-based for loop, a couple of other things to do. We need to deal with this treat 0 and 1 letter word as isograms, but we also, of course, need to set up our map, which we'll do in a moment. So why do we treat 0 and 1 letter words as isograms? Well, a word with only 0 or 1 letters cannot have repeating letters, so we should declare it as an isogram. It is very meaningful, but it'll also give us the useful behavior that when we run our game and put in a single character, like this, that it will go straight through the isIsogram test and go on to the next one, which in this case is the word length is wrong, which is useful guidance. So let's simply say if word.length, remembering it's a method so it needs curly braces, is less than or equal to 1, or you could say is less than 2 without the equals, then I'm just going to inline return true. Very simple. So treating 0 and 1 letter words as isograms. Okay, now how do we set up our map? Well, we already declared a substitution up here using hash define. We said hash define tmap as stdmap because this is the Unreal syntax. So let's use the word tmap and come down to our implementation of isIsogram and think about how we're going to set it up. Let me show you the syntax. This is the standard map syntax, same obviously for tmap because we've just made a straight swap of this to this. It's literally a textual replacement. So we're saying we're making a map of a character to a Boolean. And we're going to call that map letter scene, or you could call it scene letters or something else. But we're going to declare it like that. We're going to use the syntax using letter scene brackets letter, a bit like accessing characters of a string, to access members of that map. And you can assign to a map element in the same way with the same syntax. For example, letter scene letter equals true. Now, some people, if you're more experienced, may say, why don't you use an unordered set or an Unreal T-set? Absolutely perfectly valid alternative. I'm simply using a map here because it's more versatile. We can reuse it later in the section, and it can be used for more things than just this. But yes, it's true to say that there is another data type called T-set that you can use when you're only setting elements to true or false. You just fill it with letters in this case. But we're going to go with a mapping of the letter to whether or not we've seen it true or false. In fact, we're only going to use true. So we're just going to have a table of letter and true when we see them. So back in our code, let's actually go ahead and set that map up right now. So tmap is the keyword we're going to be using, our substituted keyword, for a character and a Boolean, a true or false. And we're going to call it letter scene. So that is how we set up our map. Now, the main subject of this lecture, of course, how do we do a range-based for loop? And what indeed even is a range-based for loop? Well, if you do a Google search for standard string in C++, you'll get to a page like this, which will explain that a string provides an interface here similar to that, highlight the right thing, an interface similar to that of a standard container. And a container is something that contains many elements. A string contains many characters. And because we have a interface similar to a standard container interface, the system basically knows how to step through the elements of the string for you. That's very handy. It's called an iterator, and it's really useful. So this is how we do it. We say for, and then we say, okay, we need a type, and we could say char. We'll deal with that in a second. And we could call it letter, so this is just the variable name that we're going to be able to access inside the loop. For letter, now, colon is the word for in. You just have to remember that for a range-based for. Word. Okay, so what this is doing as a comment here is it's saying for all letters of the word. Oh, can't type. Okay, so for all letters of the word is what we're doing there. Now, of course, we are going to have a block of statements, so I'm going to put some curly braces. By the way, if you want to put your curly braces around all these comments rather than having to mess around, highlight them and just open a curly brace. And in Visual Studio, at least with my settings, which are the default, if I change anything, by the way, I will show you the changes of settings. So I haven't changed anything without showing you. It does this for me, which it indents for me, which is cool. All right, so for char letter in Word. Now, I want to introduce you to one more concept. We don't really care what the elements of Word are. We can let go of that implementation detail and use the word auto. I would never suggest using auto up here in the public declaration of a class because we really want to know at this point what's coming back. But when we get down the bottom here in anything to do with the implementation, we can start to think about maybe we could use auto. It means that the compiler decides the type for us. In this case, if we hover over the word auto here, we can see that it's worked out type def char and then some other blurb. It's worked out that this is a character. So just trust me for now. Let's start gently introducing auto. You may see it in other people's code, and I actually think it makes a lot of sense. The compiler has to do a lot of good checking to make sure that this type is completely deducible, and that's a good thing. So just before I throw you into a challenge, I want to help you out by doing this. I'm going to make a quick substitution, or I'm going to change actually letter for to lower letter. Now, why am I making the letter lowercase? I'm changing its value, and I'm doing this because I want to be able to handle mixed case. I want to store and retrieve only lowercase letters, and that way the system will work case insensitively. Okay, let's take a look at a challenge. Finish is isogram. I want you to finish the function, test it thoroughly, try entering \0, that null character, as a guess and make sure it works for that. Try a blank string, and try mixed case, for example, AA, like that. And share your implementation in the discussions before going on. Go on, be brave.
Here's a little hint for those of you who might be struggling at this stage. It's important to note that with a tmap, if you access a value that isn't in the map yet, so even if it's an empty map, if you access the value, then it will default initialize that value. With Booleans, default initializing means that it will initialize to false. You might be able to use this in your solution to simplify things.
Okay, welcome back. So let's see how I'm going to implement it. So we're going to loop through all the letters in the word. We've already got that comment, so I'm going to remove it. So we're saying if the letter is in the map, how do we implement that? Well, it's simply a case of saying if letter seen letter. So if the letter has been, so that's the list of letters that have been seen. And if this letter's been seen, then what do we do? Well, I'm going to use a compact if notation here. I'm going to go curly braces there, and then I'm going to force it to all be on one line because I just want to keep things, as I say, in this instance, compact. And I'm going to return false. Okay? And we do not have an isogram at this stage. All right, so now I'm going to do a compact else. It's exactly the same. Remember, you need to read code like the compiler does, so I do apologize to complete beginners that I'm being inconsistent with my spacing. I'm doing it on purpose because you must learn where spacing matters and where it doesn't. Look, the IDE has changed it to this. This is the same as this is the same as this. That white space doesn't matter. You need your eye in for where white space matters and where it doesn't. It matters between auto and letter. It wouldn't understand auto letter. It does not matter, for example, out here in the ether. It's like being out in space. It doesn't matter how much gap you got between you. Okay, so now what do we need to say? So I've already duplicated that. We do not have an isogram method. So otherwise, what we need to do is add a letter to the map scene. The comment says it there. We don't need otherwise, of course, because else is pretty obvious. So I'm going to right here say letter scene, letter equals true. And this is the bit where that simplification using a set would just be a little simpler. But this is absolutely fine and very clear what it's doing. Let's make sure that this works. Let's run with \0, for example. That works. An empty string works. AA complains about repeating letters. AA complains about repeating letters. Planet, and I win. Play again? No. Great news. We've done everything that we need to do in this video in terms of getting the isogram finished. We've used this very useful and versatile map tool, and congratulations on getting this far.